Introduction to vectors. Objective: to introduce vectors and to differentiate them from scalars. Consider a bundle of few objects. Total mass of the bundle is simply the algebraic sum of the masses of individual objects. In physics, such quantities that can be described by a numerical value alone and follow the simple law of numerical addition are called scalars. Mass, time, and volume are some examples of scalars. Consider this. A boy, starting from a pole, walks through a distance of 4 meters in the east direction to reach point A. Now, let us consider the position of the boy as a physical quantity. Would it be accurate enough to say that the boy is at a distance of 4 meters from the pole? No, it isn't. To describe position of the boy accurately, we need to indicate the distance of the boy from the pole along with the direction. Suppose the boy from point A walks 3 meters in the north direction to get to B. What is the final position of the boy? Position of point A is 4 meters east and position of point B from A is 3 meters north. We cannot simply add 4 meters in one direction to 3 meters in another direction numerically to get the final position. In this case, we can use Pythagoras' theorem to get the final position of the boy. The final position of the boy is at a distance of 5 meters from the starting point along the line joining OB. You can observe that our concerned quantity, the position of the boy, has not been added algebraically. Such quantities that require both magnitude and direction to be represented and cannot be added numerically are called vectors. Position, velocity, and force are some examples of vectors. Let us look at another example. A plank drifts towards the east at a speed of 4 meters per second, while the man on the plank facing north moves with a speed of 3 meters per second. What is the velocity of the man when observed from the ground? We need to add the velocity of the plank to the velocity of the man on the plank to get the resultant velocity of the man. But this cannot be done algebraically. In 1 second, the plank moves 4 meters along the east. Meanwhile, the man on the plank moves 3 meters along the north. So, in 1 second, the man moves through 5 meters. Therefore, his velocity is 5 meters per second at angle of 37 degrees with the east. We can get the same result by drawing and analyzing vectors. Let us consider a Euclidean space. Let us call this space a velocity vector space, where only velocities are represented using arrows. Let us draw an arrow of length 4 units, pointing towards the east. This represents the plank's velocity of 4 meters per second in the east direction. We call the front end of the arrow the head and the rear end the tail. Now let us draw another arrow of length 3 units in the north direction, starting from the head of the first arrow. Now, the arrow that connects the tail of the first arrow to the head of the second arrow is our resultant vector that represents the resultant velocity in this case. Therefore, the length of the resultant vector is 5 units. This tells us that the resultant velocity is 5 meters per second. Vectors are denoted by putting an arrow above the symbols representing them. For example, V bar represents velocity and R bar represents position. Length of the vector indicates the magnitude of the physical quantity it represents. Vectors with equal magnitude and same direction are equivalent to each other. So, a vector can be translated parallelly in the vector space according to our convenience. Summary: Scalar is a physical quantity that has magnitude only and follows simple laws of addition. Vector is a physical quantity that has both magnitude and direction and follows vector laws of addition.